Spencer and Nicholas needed some help with this question, which was question 37 from our last homework assignment. A 2.5 kilogram block slides down a 25-degree inclined plane with constant acceleration. The block starts from rest at the top. At the bottom, its velocity reaches 0.65 meters per second. The length of the incline is 1.6 meters. A. What is the acceleration of the block? B. What is the coefficient of friction between the plane and the block? And C. Does the result of either A or B depend on the mass of the block? So starting with A, what is the acceleration of the block? So this question, as the title suggests, we need to combine kinematics. This first question is purely kinematics, and you might have realized that there are a bunch of numbers in here, like velocity and length, which you don't usually see in these types of questions. So let's just see all the information for kinematics that this question gives us. So starts from rest. That means Vi is equal to 0 meters per second. That's what rest means. Then at the bottom, its velocity reaches 0.65 meters per second. That is Vf. That's 0.65 meters per second. And the length of the incline is 1.6 meters. Let's say D equals 1.6 meters. And I think that's all the information we need to find the acceleration of the block. So if we have Vi and Vf, we need to use the one kinematic formula. Vf squared equals Vi squared plus 2AD. And we have Vf, we have Vi, and we have D, so we can just plug these in and solve for A. So Vf 0.65 meters per second bracket squared equals Vi is 0, so you can just put it as 0 here, or I'll write it out actually. 0 meters per second squared plus 2 times, let's put the D in front of the A, 1.6 meters times A. Now let's get rid of the exponents. So first of all, 0.65 exponent 2 is 0.4225 meters squared per second squared. Now this unit doesn't really, meters squared per second squared doesn't really make sense, but it's fine for now because it'll cancel out later. And we have 0 meters per second squared, which is just 0, so we can just get rid of that, like just cross it out. Then let's just multiply these two. 2 times 1.6 is 3.2 meters, let's put brackets, times A. And then so A equals 0.4225 meters squared per second squared. Then we have to divide by the 3.2 to move it over to this side. So divided by 3.2 meters. Then we see one of the meters cancel out. So the unit for the answer will be meters per second squared. Then we just put it in our calculator. 0.4225 divided by 3.2 is 0.1320. It's 2 sig figs, but we'll be using this later, so you should keep as many digits as possible. And we're done question A. That's it. So now for question B, what is the coefficient of friction between the plane and the block? This is the tricky part. So we should start by making a free body diagram. I'll just use a circle for this. Then we'll put it on the inclined plane later. So as we see on this inclined plane, we have, well, first of all, let's just put gravity, because it's on Earth, so it has gravity. I'll put it as Fg. Then it has normal force, which is perpendicular to the plane it's on. That's up here. Fn. Then it's asking for coefficient of friction, so we know there has to be a friction force. And it's opposite of the direction it's going, so it has to point up the incline. F. So these are all the forces we have on this object. So to solve for the coefficient of friction, we can start by solving Fg, because that's the easiest. Fg equals mass times gravity. So mass, let's look back, I should probably write down here, 2.5 kg. So 2.5 kg times 9.81 meters per second squared. Put that in your calculator. 2.5 times 9.81, 24.525. 525. And that is newtons, because it's weight. So yeah, we don't need that right now. I should probably explain something else first. If we look at the, so first we should split the gravity into its components. So make them opposite from the other vectors, make them like parallel. So FF, this direction, FGX would be this direction. Let's mark them, FGY. So, and this is a right triangle. And because the block is accelerating down, we know that the forces are not balanced. We know that Fn and Fgy are balanced because it's not accelerating like up or down. So that means that Fn is equal to Fgy. And then since it is accelerating downwards, we can say that FGX is greater than FF, because these are the only two forces that are perpendicular to the plane that it is on. So I should probably start working on this other diagram. This would be G. Okay, FN, and this one is FF. And let's also put the angle here. This is 25 degrees. And if you watched my last inclined plane video, you know that this angle is the same as this angle. So this is also 25 degrees. Now let's put FG here, FGX here, and FGY, let's just put FN because we know they're both equal, so this will make things easier for us. Now, when I said FGX is greater than FF, we can do something more with that. See, the only two forces acting on the block which are parallel to the plane are FF and FGX. And then we also have an acceleration here. That is part of FGX because that's the only force that can bring it down the plane. So let's calculate the force of that acceleration and we can figure stuff out from that. So FA, A stands for acceleration, equals mass times acceleration, equals mass 2.5 kg times 0.1320, and meters per second squared. Then calculate that. 2.5 times 0.132, that's 0.33 newtons. Let me just check if that's what I got here. Yeah, so 2 sig figs. It's already 2 sig figs, so I don't need that. Now that we have FA, we can determine that FA is equal to FGX minus FF. If you don't understand this, FF is the force pulling it up the plane, FGX is pulling it down, and FA is the net force. So that is the result of these two forces together, so it's the sum, or in this case the difference, because I like to subtract in the here. So this is how we'll find FF, which we need to find the coefficient of friction. Now what we already have FA, so now all we need to do is find FGX. So we have FG and we have this angle right here. So we can solve for FGX by using trigonometry. So FG is hypotenuse, FGX is opposite to 25 degrees, the angle we have. So that means opposite over hypotenuse, that's sine. You can use sine to solve this. Sine 25 equals FGX over FG, what was that? 24.525 newtons. 2 sig figs. So now we just solve for f dx, multiply sine 25 by 24.525 and 525. That gives us 10.3647. I'll keep lots of digits. Newtons. And sig fig on the unit because it's 2 sig figs. Now that we have this, we can plug all our values in here. So FA 0.33 newtons equals, what did I just get? 10.3647 newtons. 0.3647 newtons minus F. Now subtract both sides by 10.3647. 0.33 minus answer, negative 10.0347. Then subtracting rule for sig figs, we take the least precise one, which is the unit, so it'll be still 2 sig figs. Then equals negative FF. So both are negative, so we can just multiply both sides. I'll just erase the negative sign, and then this is what FF equals in newtons. Now, if we write down the formula for coefficient of friction, FF equals mu k times Fn. We have FF, now all we need is Fn, and then we can finally solve this. Fn, this is what we did in my inclined plane video. We just need to find the y component of Fg. So that is the opposite of what we did to find Fgx. We just use cosine instead of sine, and then replace the Fgx with Fn or Fgy, whichever one you want. Cosine 25 equals Fn over 24.525, which is Fg, the hypotenuse. Cosine adjacent over hypotenuse. Adjacent is Fn, hypotenuse is Fg, so that works. Then put in your calculator, cosine 25 times 24.525. Then we have Fn equals 22.221, 72 newtons and 2 sig figs. Now we can finally use our formula. FF, what was that again? 10.0347. 347 newtons, 2 sig figs. I'll try to hurry up now. Mu k. Fn 22.2272. 72 newtons, brackets. Now just to solve for mu k, divide both sides by Fn, 22.2272. So 10.0347 divided by answer gives us 0.45. We can actually round this one because this is our final answer. And that is our coefficient of friction. So now all that's left is C. This isn't really, can't really explain this with physics. Can't really do any calculations to prove this, but does the result of either A or B depend on the mass of the block. So let's just look at A. Do we ever use mass here? No. So that is our answer. A does not depend on the block, on the mass of the block, because all our variables have nothing to do with mass. Now if we look at B, we do use mass a couple of times here, here, and yeah, there. So normally your first thought would be, yes, it does depend on mass. That was what I first thought. But actually, I can't really explain this, but when you add more mass, add more mass to an object, its friction also increases. So if we look at our diagram here, if the friction increases, if we add weight or add mass, then the friction will increase, but also the weight will increase. So the F3x will increase, and they'll always have a higher acceleration going downwards. But what our answer for B was the coefficient of friction, and the coefficient of friction does not depend on mass. It only depends on the surface of the block and the plane. So I hope that answered your question. I'll have another video out soon. Thanks for watching.